It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leandro Facchinetti, and let's write some code together, shall we? Shall we, Arya? Shall we write some code together?
Let's do it. Yes.
Let's do it then. So I guess we are changing things up a little bit. Usually we do coding on your channel and we talk about audio production on mine, and we are going to do that in reverse now. We are going to talk about audio production on your channel and we'll be coding on mine.
Yeah, I was just seeing that like 3 people watched the streams and they all know your channel, so maybe there'd be more people interested in scripting on your channel. And then what we do with you on your channel normally, I think maybe some people on my channel would enjoy, and maybe when we look at synths or effects or whatever, like when I do my mixes on my channel, I sometimes get a lot of good suggestions, so that could be like beneficial.
Yeah, I remember we had, when we were working on some of the songs on my channel, we had some great feedback on like plugins that I could try and techniques that I didn't know of. So definitely learned a lot of stuff from people there. So looking forward to doing that on your channel in the near future, I guess on Friday, right?
Yeah, and if we saw that it's like, we can always change back, whatever.
We'll see.
Program.
We'll see. Yeah. But what we are working on today is actually a follow-up to what we have been working on your channel. So probably people who know one of us know the other one and are subscribed to both if they're interested in scripting. But let's get into it. It's this plugin that is a pitch shifter. We are getting into the theory behind how a pitch shifter works. And if we sketch something out, but it is rough. It doesn't work that well, and I think I know the reason why. I promised that I would fix it. I didn't, but I thought about it, and I think I know why it has the bug that it has. And we'll try to fix that. We'll clean up some things, like we didn't know exactly what to name something. We named it whatever, so now let's produce proper names. We'll also try to use my library that I have been developing over the course of 4 months now. And the library has features like a circular buffer that we can use here. And we'll also try to augment the library with some new functionality that is needed. Like currently in the circular buffer in the library, you can only get samples, but you cannot get interpolated samples between the collected samples. So I think we'll need to have that in the library, which is this part. And
do you have in your library something that can act as like a toggle button, or just like a button, not like a slider and not like a drop down? But it could be a drop down kind of behind the scenes, but just be a toggle from the user interface.
We don't have anything like that, and I am currently avoiding some things that, to do a proper toggle, we would need to have something on the UI that you click, so I would need to listen to mouse events and all of that. I haven't really gotten into that. I'm trying to get away with only sliders, but we can try to mimic a toggle with a drop-down menu. Now, my question is, what do you have in mind?
So what I had in mind, have you ever played around with the Roland PS6 Harmonist pedal?
Roland? No. The answer is no, but let's try to get it on the screen.
Okay,
PS6,
yeah, get a picture.
60.
Yeah. No, I think it's PS6, but whatever. It'll probably show up.
You are right.
Yeah, that one. Yeah. So like sound-wise, it's similar to the Digitech like whammy bar, but it doesn't have a pedal. The way it works is that you give it a ramp up and a ramp down time, and then you press the pedal button, and it goes wee, and then it comes like a when you release. So instead of like having a pedal, you just with a single button like control it, and then you can give it a kind of final destination pitch to be, and then how long it takes to go to and go back from. So that would be really nice to implement into the pitch shifter, and then like assign it to like a button.
Interesting.
So maybe with sliders you control like the parameters, and then the button does it. So that you can also be precise instead of like if you use a pedal, it's hard to be precise on a pedal.
Yeah, you're right. That's interesting. We can definitely do that. There is this, besides the drop downs and the sliders, there is also triggers, and they are not terribly interesting or useful in JSFX, I don't think anyway. There are not that many JSFX using the triggers, and I think that the reason is that they are not fully featured. You can only have so many triggers, and you cannot have less than that. So I think it's 8, and then if you use triggers, all 8 of them show up on the screen, and you don't have any user feedback in terms of what they do, so you have to sort of read the manual. It isn't great, but we could try to use that.
So it's part of EEL2. It's not like a workaround that somebody made.
It's part of EEL2. You're right, yeah.
Oh, okay. Never seen it.
Cool. I think I can show you an effect that uses this. If I remember correctly, we were talking to Justin about the spectral hose. And
spectral
it uses
paint? Oh, okay, cool.
Yeah. But you see, it's not 8, it's 10. So there are these 10 triggers here, and what do? You have to go into the source and learn there what they do.
I see.
And we could use triggers for this because it is sort of a similar concept. I don't know if it's possible to, because ideally, I guess the use case for this would be to trigger this with a MIDI pedal. Right? So for that, we may be able to assign a MIDI message to these triggers, but I'm not sure if it's possible. But it's definitely possible to assign a MIDI CC message to a slider. So it's either on or off. So we could have a slider with 0 and 1, and then you could just play it with your mouse, or you could write automation. But you could also assign it to a MIDI CC, and then that will trigger the thing. So we could do that, I guess.
Right. Cool.
Right. Okay, we can look into that. But first, we need to have a plugin that sort of works. So let's go over the code for what we had last time and start playing around with this, maybe improving it, maybe fixing that bug. Let's get to it. I'm going to create a buffer here that I will call LEAFAC or IDDQD LEAFAC pitch shifter JSFX. And I'm going to load this into Reaper because I want to hear what we have before we start working on it. So,
sure.
Well, the name is just pitch shifting. And right now there's no audio going through this. What's some good sound source for this? Before on our channel, we were like
pad.
We used something like an instrument. I was thinking about using just a sine wave.
Yeah, works. Yeah.
Okay, so I am going to put on the track an tone generator, and I am going to make sure that we will all be able to hear this. So
actually, it would be interesting with a sine wave because I'm wondering as you go to extreme ends of pitch shifting, is it going to introduce overtones? Because like the way it's squeezing the sine wave is like, imprecise. I don't know.
Well, especially at the edges of the circular, at the grains, at the edges of the grain where we are doing the crossfading, that will be weird, I think. So, yeah, I think it will introduce some distortion.
Cool. Let's check it out.
Let's check it out. All right, so I'm about to add a tone generator to the track, so I'm going to mute the master, and I'm going to say hello to Bo. Bo is here. Hey, Bo.
Hello, Bo. You know what I do with when I want to add a sine wave and stuff? Because, you add it as a plugin, it immediately starts playing. But if you create an empty item and add it to the item, then it will only play when your playhead goes over it. And then you can glue the item and just get a regular file as well.
That's smart. That's smart. Yeah. And it's easier to play and pause and everything. Yeah, that's interesting.
Right.
Yeah. I'll do that then. But it does make it harder to change the note.
I mean, you can glue later if you want. You don't have to glue right away.
Yeah, but whatever. I'll just leave the tone generator here, and I will control the slider here for us to hear when we want to hear the thing. But Bo is also saying, what about a mouse over function in the GFX section? You probably mean for the pedal thing that Arya explained. And yeah, we can. We will get into the mouse stuff in JSFX. It's something that I'm trying to delay as much as I can because it's annoying.
What do you mean by mouse over? Like your mouse goes over a slider and that's already doing the adjustment?
Maybe. What I understood was that we would have a GFX section, which we currently don't, but we would have some area where when you put your cursor, that means activate the pitch shifter. And when you take your cursor off, it stops.
By the way, this is again kind of tangential, but did you see the Maui EQ?
No.
Somebody wrote a very simple EQ, using the cookbook and the Garant Luff, Maui, MAWI. And they credited me and you as some of the people who taught them how to do it. And look at it. It looks so good.
Yeah.
Yeah. I definitely want to put more energy into learning GFX. I attempted a few times to go through Garant's library, but I just got stuck at one point and I never got past it.
Okay, the documentation I think is very good, and
it's very good. I think I'm very dumb.
No, it's not that. Maybe it's very good, but it's written for people who have more background in working in other languages doing graphical user interfaces. Because it does have the concepts of stacks and it has a layout system. It can be tricky if you have never worked with that, but it's reminiscent of layout systems in languages like Java. If you're doing, back in my day, Swing, and I guess today it would be JavaFX. Those are things that if you have worked with them in the past, it's a natural concept. You just see, oh yeah, of course, it's doing that. But if it's your first time being introduced to the concepts, and the language can also be kind of weird. JSFX has some weird abstractions, so especially when you get into pseudo objects.
Yeah, I remember one was drawing screens, which I was like, what? And then after a while I realized each screen is a page. If you go to the options section, that's drawing a new thing.
Yeah. I mean, this library is a lot about abstractions, and I mean, there are options here. There is even something that is kind of crazy, and people have been requesting on ReEQ forever, and just seeing is no, let's not. Which is, using this library, you can type in specific values for inputs.
Yeah.
And that is done by capturing the keyboard and doing a lot of crazy stuff like low-level stuff to control the cursor and everything. And that is just such a pain to do. And the library does that for you.
But
So-
you can type in REAQ, no? You can just type in next to the slider.
No. I guess we have different justings and different requeues.
Oh, sorry. That we did have different. Yeah. I was thinking of the other one.
Yeah, and Bo is saying, like a colored square or button in the JSFX window that you press. So yeah, he had that idea in mind for like what is the trigger essentially of this.
Yeah, I would eventually for sure want that, but yeah, let's I guess do the audio and then get to JSFX at a later date.
Right. So, how are the other pitch shifters called? Let's see. Pitch shifter, shifting, shifter. I guess it's mostly pitch shifter. So I'll go with.
We should give it a nice name that is something else, you know. We should give it a name that's so that people know that it's
okay, now I hear you. What did you say?
I said we should give it a name that makes it obvious that we're trying to emulate like a whammy bar. You know.
Yeah,
Ria Wham.
that can work. Yeah, Ria Wham. Is it like this? I guess it's whammy.
Yeah.
So wham.
Yeah, Ria Whammy. I think that's even better because that's very clear.
All right. And I will put in parentheses pitch shifter.
Yeah.
It helps when you're
so
searching.
It shows up in searches. Yeah.
Yeah. And then in terms of sliders, now let's take a moment to consider what sliders we really want to present. Because I think that maybe this one, for instance, we may not want to present. So right now, and I said that I was going to hear what we currently have, and I didn't. So I got sidetracked. Let me put this sine wave, and I'll make this sine wave not as annoying.
I noticed something interesting. Can you put the pitch ratio at 1.5?
This just sounds so fun. It sounds like a robot in a TV show in the 90s. But yeah,
like
okay.
a Doctor Who robot.
I guess.
And unmute it. And then unbypass it. So that's interesting. It's not a fifth. No, it's a major third. But 1.5 should be a third.
Okay, right now we have an A2 as expected. And then we have, look at that.
Yeah.
We have the major third.
So we should investigate that too. Our pitch ratio may not be exact. Or I guess let's try 2 and see if it's octave.
Nope.
It's a fifth. Okay, yeah. So all right, well that's another thing that we gotta wamp out.
But if it's 4, is it an octave? No.
It's it's an octave plus a major third.
Yeah, it's
The 3 is an octave. Okay, cool.
I wonder why that is.
How is 3 an octave? That's such a weird.
Let's look at the buffer size. If it has any impact on
Yeah.
this, it does not. Okay.
On a sine wave, it's hard to hear the buffer size difference because the tone itself has no like envelope.
But I was thinking of maybe the buffer size was so small that the edges
for the
were kicking
tuning.
in and changing the nose. Now that would be surprising, but it didn't hurt to test. But yeah, also I want to put an oscilloscope because I have a theory of what's going on. And I think we did this last time when we put an oscilloscope and we saw these little bumps.
Yeah.
Like this one. And this is like the crossfade. Oh, so maybe my theory is wrong. I was thinking that there was a discontinuity in the crossfade, but that doesn't seem to be the case. There is no discontinuity.
It's just a volume drop.
So maybe it has to do with the way we are doing the crossfade. We are doing the crossfade with ramps that are linear. Maybe we should be using logarithmic or exponential, however you want to think about them, curves, because they will add up to unity.
Yeah. I think equal power versus equal gain. I think we're using equal gain. We need to use equal power.
And yeah, okay. I see all these little bumps, and I guess those are the clicks that we hear. They have to be, right?
Yeah.
Interesting. So now, the problem that I think we had is maybe not the problem that we have. Interesting. Because you know what? I thought about this a lot, and I thought that the problem was, I will dive into the code here a bit, but we are going to go over this in detail, so let's not get too hung up in the details. But we are doing this trick that is, we get the read head position and then we compute the grain. Okay, yeah, here. This grain is a different base value for the buffer. So we have a big buffer that is 1 second long. Because at most your buffer size will be 1 second long, so we keep a buffer that is 1 second long. And if you want to use only 100 milliseconds for the grain size, I guess this slider maybe should be called grain size, because this is really the grain. The grain is a slice of the buffer, and the grain can be shorter. The buffer is always a second. The grain can be shorter. And the way that we are doing this, the way that we are using this to actually slice the buffer and make up the grain, is we get this different address. We take the buffer index and subtract the buffer size. So in other words, we are just taking a different base address into the memory, and then we use that base address. But what my intuition was telling me was that at the end, when the slice of the grain, so maybe I will, instead of trying to draw a diagram with my hands, I will draw a diagram with ASCII arch. So we have here our big buffer, and then we have a slice of this buffer, which is the grain. And as the read, the write head, as the write head or the read head, because in this case it doesn't really matter all that much. So as the read head advances on the buffer, so I'll put the read head here, the grain also moves forward. But then there is this situation where the read head wraps around, because this is a circular buffer after all, and then the grain needs to be something like this.
Oh, okay. Yeah.
And I thought that in this situation we would have an issue, because I was not taking in account this wrapping, which means that I would try to index into the grain instead of, for instance, if I wanted this position into the grain, I would not be wrapping around as I should, but using this base address instead. So I would be here and reading memory from the right-hand side, which we are currently ignoring. We have this grain right that we are not using at all. We put stuff in there, but we don't read stuff from there, because the effect is mono for now. So I thought that in this case, we would be indexing to here, and if this is the buffer for the left side, then we know that because we laid out memory this way, this would be the buffer for the right side, which is always like something related, but so maybe I am right. Maybe I am right, because Okay, I think that this could be an issue still. And
yeah, I was gonna say like this may be an issue that we can't pick up using just a sine wave, because sine wave itself is not a very changing entity. So maybe if we use like a more complex waveform, like those troubles will come through.
you know what? It's not even that. Because so we are writing here, right? So remember how you were playing a pad and we could hear a click or an artifact every like second, and it didn't matter if you changed the grain size, you would still hear the artifact at the same point.
Yeah.
That's why I thought that this was an issue. And then now we are having sort of this different issue. And I just looked at the code and check this out. We are writing to the right channel as well. So if it gets into this position and here it's going to look into the buffer right, it's still going to read something because we are writing the sine wave to both the left and right channels. And the sine wave is a mono signal. So it's not that the sine wave is too simple of a signal. It's that the sine wave is mono while your pad was stereo. So here we were getting junk from the right channel and mixing that with the left channel. That's bad. But now we have a sine wave, so the left and the right channels are exactly the same. They're mono. So even if you had a complex pad, but if it was mono, we would not be hearing that click.
Gotcha.
Isn't that
here's
interesting?
a side question as well. So I think the way like I'm trying to think of one, like the isotope dynamic delay has this. It has a pitch shifting delay with like a grain size, but I think the way it works is changing the grain size just changes their like read buffer size instead of them being two separate entities. Like, so why like why are we having these two things be different? I kind of remember you saying like, well, if we change the size, there needs to be something there to be read, otherwise it's emptiness, right? But wouldn't that emptiness just happen in the space of like a few hundred samples of emptiness?
Yeah, and a few hundred samples is, or even just one sample can be a click.
Yeah. I guess, there's like we can loop the grain and then, but I think that makes it really complicated. Okay, so I'm with this grain and buffer situation. So we just gotta solve for left and right action.
Yeah, we have to solve this wrapping of the grain. We have to solve the crossfade. Let's start taking notes because we identified some issues already. So there is the issue of cross fades should be exponential logarithmic power instead of linear.
Equal power, yeah.
Should be equal power instead of equal amplitude. And then there is the issue of grain wrapping. And actually, Arya, there is another reason why we have this buffer and grain situation. Besides just changing the size of the grain, or besides just having silence in parts or junk in parts of the buffer as you increase the grain size, there's also the issue of memory allocation. You don't want to be allocating memory in the sample block for sure, and you want to avoid, unless it's strictly necessary, you want to avoid allocating memory in the slider block. You always want to allocate memory in the init block. So, and the reason for that is memory in JSFX pretends to be a big buffer that is pre-allocated for you, but in reality it isn't. It is allocating memory under the hood for you. So as you access memory further up, it's going to be allocating memory for you, which is annoying. And also, it's just bad practice, and the whole memory layout may change when you are allocating memory. So it's always a better idea to just allocate the whole memory in the init block. So even in this plugin Isotope did, I bet that they are allocating my memory beforehand, and they have some notion of grain size. that is like a slice of the buffer that in which they actually write stuff to. Also, they may be using something else entirely. I mean, there are other ways of doing pitch shifting. You could be like, there is this thing called the short time Fourier transform. So you take the Fourier transform of blocks, successive blocks, but you don't take blocks that are like one next to the other. You overlap them, because you want to window the FFT to get rid of some artifacts on the discontinuity, because the FFT wraps around. So in any case, there is this overlap between the windows, and in this overlap, if you overlap the things when you are doing the FFT, you are going to have to overlap the blocks on the way out when you're doing the inverse FFT, right? So what happens if you take the hop size? So the hop size is this amount of samples that exist between one block and the next. So if you take the block size, the hop size on the analysis part, on the FFT part, that is equal to the hop size on the way out, on the inverse FFT part, on the synthesis part, then you will get back exactly what you put into the system. As long as the hop size is, the hop size and the windowing and all of the other things that are related align, you can do a transformation that doesn't lose any data. You can go into the frequency domain and back without losing any data in the middle. Great. That's what some plugins do, like REAPER does something like that. If you have REAPER on a track and it's processing audio, but you don't have any EQ or compression going on, it's not going to change the audio. Great. Or at least I think it doesn't. I don't know. I haven't really checked, but it stands to reason that that's the case. But what happens if you take the hop size of the analysis of the FFT and you let the hop size of the synthesis or the inverse FFT be a different hop size? But if they're different, then time is constantly stretching or constantly expanding. You can do a pitch shifter using that as well. And that's kind of crazy. They may be doing that. So who knows? It's hard to tell what the plugin is really doing unless we have some more information, I guess. But yeah. Okay. So I think that this idea of having a buffer and slicing it does make sense, right?
Yeah.
Okay. And those are the only two issues we found so far. So this is actually the grain size.
Yeah.
And Bo is asking if that's what post stretch is doing, this whole idea of the hop size I just explained. I don't know, Bo. I don't know how post stretch works.
I think pulse stretch works like similar to like a granular synthesis. So it takes small chunks of your audio and loops those so that you can have, because like if I take a 2-second file and stretch it, eventually I'll get to frequencies that are subsonic. But if I take like a chunk of it, enough to give me a sense of whatever the pitch is, then I can take that, and by looping that and crossfading the loops, I can create an elongated note. So one thing that pulse stretch will do, if you put like something with like a big transient on it, you will see that the transient becomes longer and then the tail becomes longer. So it's just going through the file and chopping it and looping each chop X times to get to this final amount. There is some pitch shifting that you can do to it, but if you do no pitch shifting, you can take like a 10-second file that make it 10 hours long, and it would just figure out, okay, I'm gonna slice this 10-second file into like 1,000 pieces and loop each piece like whatever 3,000 times until I reach 3,600 seconds. Don't check my math on that explanation.
Yeah. Someday I will probably get into what post stretch is really doing. I don't know.
I think you can't. Monterey not support it. It needs to be pre-Catalina as far as I understand.
But I can always read the source, right?
Oh, yeah.
Okay.
Please read the source and make it for Monterey, Leandro. Okay, thanks. He promised everybody. You saw it here.
You heard it here first.
You heard it here.
Right. So, Bo says, all right, but can you set an FFT size? But you can set, it's an affirmation, not a question. You can set an FFT size in post-stretch, which affects the sound. So maybe each one of these grains are being processed with FFTs in the way that I explained. I do know that it's using FFTs, I just don't know how.
Yeah, I mean, it very possibly does, but I think the hop, what was it? The hop size?
Yeah.
Was it size? I think it doesn't do that. I think it just, because also if you put a file, like one thing you can do with pulse stretch, like take like wavetable that's like very distinct looking waves and put it in pulse stretch, and you can actually see like the chops and the fades and more chops and more fades. Because it's offline, right? So it doesn't necessarily need to do all of this like time domain, frequency domain things in real time. It can like take its time. You know what I mean? But yes, you could say like chop them into this size pieces or like this size pieces.
Mm-hmm. Yeah, and Bo says that post-stretch sounds amazing. I want a light version of it that processes in super small increments. Yeah. You heard it here first. I'll get to that at some point. Right. So we have this pitch ratio, the grain size, smoothness. We may not want to present all this to... Oh, and did we hear everything we wanted to hear from this? I think we did, right? Yeah.
Yeah. By the way, you were saying, and this is the last tangent, you were saying like smoothness is not something you may want to show to the user. I think I would want that to play with. Like maybe I want to like move the mouse, but I don't want necessarily the value to move as fast. You know what I mean? Almost like creating a drunk object. I don't know if this exists in other software, but in MaxMSB, there's an object called the drunk object. So what you can do is like you have a slider and your slider goes between 0 and 100. You can assign a random object to it. So it picks a value from 0 to 100 and puts it into that slider. But the drunk object is like a drunk person stumbling. So if your slider is at 50, it still works randomly, but there's more weighting around the value you're at. So it goes 51, 50, 49, 51, 52, 53, 51, 48. You know what I mean? So instead of being fully random, it's like random around the central position. It may stumble a little bit this way, stumble a little bit that way.
But does it always does it always stay near a value?
Yeah.
Interesting.
It like eventually returns to that value, but it may go like very different kind of directions. It may go really far from the value, but eventually kind of comes back. So I think it is random, but with weighting assigned so that it's more likely it's near the value.
So you know what that is called? That's Brownian noise. That's what this is.
Oh yeah, that's right. I watched your stream where you explained that. Yeah, that's really cool. So I was thinking with the smoothness at a very high amount so that it's slow, and then just using the random LFO to assign to it, we can make a drunk pitch shift with because if the value is really far, it'll take a while to get to it, and by the time it gets there, it may be headed in the other direction and stuff.
Interesting. I mean, I think that what you're proposing sort of boils down to having an envelope that goes up and down in kind of a Brownian way, and you could just assign that envelope to the, I guess, this to slider 1.
Just the, yeah, exactly.
But there is no easy way to get the Brownian envelope. So we could sort of encode that in the plugin itself. And also I think that having that as a slider can make things easier, and then you will get results that you wouldn't otherwise because of the workflow. So interesting. Yeah, and what's the most interesting part of all of this, for me at least, is that Brownian noise, it models things like dust in the air, and it models like molecules of perfume in the air. It models these kinds of things. So it doesn't always return to a given value.
Right.
If you look at dust in the air, it does go somewhere. And also molecules of perfume in the air, they will go and occupy as much space as it can. It will fill in the room. So this drunken walk will get somewhere. But in this case, it seems like they are either doing what I did when I implemented Brownian noise, which is to wrap around, so you constrain the range. So if you try to step outside, you bounce back in. But another thing they could do is they could weight, like you mentioned, they could weight the walk. So if you're trying to walk away from a certain value, there is more resistance. And you would implement that by just changing the way that you take the random number. So if you just take the random number and how do you do that? I guess you can just like divide the random number that you get to weight it against the difference. So you just take the difference between the value where you are and the value where you would like to be around, and you weight that random number so that you cannot go too far away, or that it's improbable that you will go too far away.
What's like we did another kind of interesting experiment with the drunk object, which was there was a slider and it was going from 0 to -100 to +100. And we all ran it at the same time, and it was about half whether, and it would stop if it got to 100 or to -100. And about half it got to 100 and -100. But what was interesting was the time it took. For some people, it took like 3 hours to finally reach like 100 or -100. For some people, it happened in like 10 minutes. For some people, it happened in like 1 minute. So it's very drunk. Yeah.
I think that there is probably some fundamental truth to this, and there is like an equation that tells you how, if you ran this experiment in infinitely many times, how many times you would get 1 minute and how many times you would get, I guess, forever, right? Because in theory, it could be running forever. And probably there is some equation to this attached to the name of a French mathematician, but I wouldn't know. And Bo
the
is even
Monte
asking
Carlo
if this is
equation.
Yeah, I don't know. Maybe it is. I don't know.
I remember Monte Carlo from like poker stuff, like a game theory principle. So I don't know if it's the same thing.
Yeah, I know that Monte Carlo is something related to randomness and probability, but I forgot. I had a statistics course 15 years ago, so some things I forgot. Right. So maybe this smoothness can be interesting, and I guess we will not get to most of what I promised in the beginning, but it was fun to have all these conversations. Right. So in the I guess coming back here to the sliders, there's something that I want to do in the code here that is just stylistic maybe, but I do think that using numbers like slider 1, 2, and 3 in the code isn't the best, because what if we want to switch these sliders around in the future, which is also not the best thing to do, because then previous versions of the plugin will be incompatible, but we could write a migration thing. So yeah, whatever. I'll just rename this. So I will give them names like pitch, ratio, slider. And you may be wondering, why do I say slider if it's a slider? Well, it's because in some cases we will want to compute based on this. So like slider 2 will maybe be called grain size in milliseconds. And this may be the grain size in samples. But the pitch ratio, I don't think we actually do any computation with it. Yeah, it could be
It's
just the
still
pitch
good
ratio.
to do that.
We could just have it like this. That will do. And the grain size in milliseconds, and then this smoothness is given in milliseconds. Okay. We are doing slew rate limiting with smoothness, isn't it? Yes.
Yeah.
No.
We're ramping, no?
Isn't smoothness like... We are ramping, that's right. That's this speed over here. But
Yeah.
speed is related to the pitch ratio. So there you go. This is the pitch ratio slider, because we will have a pitch ratio for real, which is the smoothed out version of this pitch ratio, the pitch ratio. But there is something else here. This smoothness situation looks like the crossfade, right? Because look at what we are doing. We are converting it from milliseconds to samples, then we are taking it in account when we are computing the position of the read head. So that must be because we have a crossfade. That's the crossfade situation.
How I remember it was that smoothness made like the change between two pitch ratios faster or slower, but I may be remembering it wrong.
Yeah, that's the value that works well.
Okay.
And I guess if I just say crossfade, it's clear that I'm talking, especially given that it's in milliseconds, it's clear that the crossfade, it's the crossfade duration, right?
Right. Yeah.
Right. So we now need to look at every place where we have slider 1, and that's only this place, and we replace that with this. And then slider 2, we replace that with that. Are there other occurrences? No. And then slider 3, also only one occurrence. And this is somewhat new in JSFX. I guess, like Justin said, it's 5 or 6 years old. So you will find a lot of JSFX that don't use these names and that do sliders like this and that compute stuff on the slider block just like that. But I prefer to have it like this. So
Right. You can also, I guess, like before this was introduced, you could just set slider 1 to a variable name and use that, right?
yeah, I guess the intent was that in most cases you will want to pre-compute something based on the slider, so why bother, right? And then in the case that you do want to just use the slider with a certain name, I guess 6 years ago you would say like my variable equals slider 6, for instance.
Right.
You would do something like that if you didn't want to compute. But in most cases, you will want to compute like it's the time, what is it called? The time constant. So you would do something like that.
Crossfade can be one word, by the way, with no dashes. It's allowed now.
Let's see what other people do in JSFX in general. Cross... Polyphonic, no. Crossfade. No one does crossfade with a dash.
I think nobody does it in the name, but maybe in a pitch shift situation, like you gotta have one, no? Like
no, yeah, I'm just saying that people tend to use without dashes. You were right.
Oh, I see.
So far so good. I think that maybe I could call this just pitch ratio, and then I will have a smooth version to make it clear that we are smoothing things out. Right, so I'll have it just like this, and for now at least. Then in the init block, we do have this situation here where we are doing this ridiculous thing that we divide 1,000 by 1,000 and then multiply by 0. That's only because we don't have the library here, but now we do. So import liafac JSFX inc. Now we do have the library, so we can do what we wanted to do, which was to convert this, which is given in milliseconds, to samples. 1,000 milliseconds into samples. Oh, and even better, this is the base address of something, so we could allocate a circular buffer. And we had this conversation many times, but I forget what we decided to do. Do we want to have this as a multi-channel thing? I guess we decided that we will have multi-channel as an option,
We said
right?
stereo is fine, multi-channel as an option.
Okay, so I will call this circular buffers, and that will be the number of channels. We will need a serialized block for this to work. I will copy the serialized block from something like the waveform, just because I do need a serialized block for the number of channels to be available here. So I might as well just use this to store the version in case we do need to migrate the sliders in the future. That's how we are able to tell that we are migrating. Right, so the number of circular buffers that we'll have is the number of channels. So we'll do, let's do an array of the number of channels, and then we'll do channels, channel equals -1. You have seen me writing code like this a couple of times already, so I think that you will recognize this, right?
Yeah. Hey, we got 6 people watching. Moving the streams worked. All right.
Hello, everyone who's
From
looking
our
around.
usual 3. Oh, 7. Fuck. Get out of here. No, just kidding. Please stay. Oh, I said that and they left.
So we can have a constant here that is like the maximum, or maybe even grain size maximum. Or I think that I will rename this ever so slightly to be grain
Sure.
dot size, because we will have grain as a variable at some point.
Right.
So this is the name convention that I'm using. I put dots to separate different concepts, and concepts may have multiple words, like in this case, pitch ratio, I guess. So if I had to do something like this, I would do something like that. I would separate the concepts with a dot. Right. So the maximum that we have is this. And now with this, we are using the library to compute essentially what we had before. And look at that. The library is smarter. It's multiplying instead of dividing, which is faster.
Oh, fun. Cool, cool.
I mean, the JSFX compiler may be smart enough to see something divided by 1,000 and rewrite that into multiply by this, but but I don't know. Multiplying tends to be faster than dividing, so it's good that we did it that way. So you have the maximum here, then we are creating a bunch of circular buffers, and yeah, let's have this as like a circular buffer, and then we have a grain, which is a slice of the circular buffer. And all of this looks good. So then we can get rid of all of these guys. And the write head and the pitch ratio are initialized here. The write head we don't need to initialize. The circular buffer will take care of that for us. But the pitch ratio is something that we will want to initialize. So this speed, I'm going to rename into pitch ratio smooth. I don't know.
Sure.
We call it the follower, but whatever. So again, this value needs to match this one. And I think I can do it like this. I think that these variables are available and already initialized in the init block. But I am not sure. So here's what we are going to do. I'm going to take all of this code out and put it here in this temporary buffer. And then I'm going to save just so that I can reload the plugin into the track. And then I will look into the variables here on the right. And yeah, it checks out. The pitch ratio smooth is 1.5. So that's cleaning things up a little bit, I think. Looking good. Then what do we have on the slider block? We will compute some stuff like the grain size in samples. Not samples. I said samples and I wanted to write sliders, so my head got mixed up. So the buffer size, the value that works well in the smoothness. Let's maybe just move this here, and the buffer size, or maybe let's move the whole thing back. So this buffer size situation, we want to rename because it's now the grain size in samples. And I only want to rename when it's not max buffer size. So I guess I will do this by hand. This is going to be the grain size in samples. Why do I need to have the grain size in samples? As I have the impression that this is only going to be used for computing stuff, and this is already... Oh, no, okay. I thought that maybe I could get away with just pulling this information out of the circular buffer, but we are really talking about the grain now. So maybe the ideal solution for this issue would really be to introduce the notion of slicing the circular buffer in the library. But let's not get ahead of ourselves. We'll first do it here and then maybe pull it out. And I do have, I guess it's again milliseconds to samples, right? So I can just take the grain size in milliseconds, convert it to samples like this. And I like the way that this line reads.
Yeah.
Then this value that works well is something that is embedded in the follower. No, it's not. So maybe it should be. We should have a value where this is embedded, because this is a value that I calibrated and it seems to work well, at least for gain. So it may work well for other things. So I'll do a version of the follower that takes the follower and the target, but does not take the minimum change. Just because I will call follower with a default minimum change, which will be that value that works well. Have you seen this before, Arya? I learned about this recently.
No, I don't think so.
Yeah, I learned about this when I was reading Gerent's code on the stream, actually. But you can define a function with the same name multiple times as long as...
Oh, like a pseudo object, right?
It's not even pseudo objects. You can do stuff like function f, argument a, function f, arguments a and b, as long as the number of arguments is different. And
the function is different.
And you tend to want to put the function with the most arguments at the top because you tend to want to call that other version with a default value. So you tend to want to do something like this. And you can only call functions that appear before you. So if you wrote it the other way around, it wouldn't work. But yeah, so when you call f anywhere else in JSFX, if you call f with just a number, it's going to call this version. If you call it with two numbers, it's going to call that version.
Ah, okay. Yeah, I remember you guys talking about it. I remember I didn't like fully get it, but okay, this makes sense.
Yeah, I don't think we talked about it at all, actually, because I didn't know this was a thing. But this allows you to implement default values for functions, just like this is default value for b. And it allows you to even change the behavior of the function, because nothing prevents you from doing something else entirely here. So over here, I do like a plus b, while here I do like a squared. I can. And this is something called function or method overloading, or I guess in some cases just default arguments. But yeah, it's interesting that JSFX does this. since it's such a simple language, I was expecting it to sort of like disallow the same name to be used multiple times. So, right. So now this value that works well, we don't need it anymore because this line that is doing the smoothing is something that we can just use the library for. Follower of this and what are we following? We're following the pitch ratio. And then we can get rid of all of that and get rid.
Can you put that back for a second? Okay, so wait, all of that you got rid of with your follower. How?
Look at the body of the follower and what we were doing before. Now I will rename this variable. I'll call it target. And I will rename this variable. I'll call it follower. And I will rename this variable.
Then maximum change.
And before we had a plus equals.
Yeah.
That I changed. So
I see. Okay, gotcha.
This gets rid of this part.
So if I'm making like a new JSFX and I want a value to ramp, this is all I need. I need the follower. I need like the parameter that I want to ramp, and I need the value that I need to ramp by. And what's the third thing that I need?
Well, if you want, you can say what is the maximum change that you can apply to the pitch ratio.
Okay. And that's optional.
Value. But that's optional, yeah. By default, it will be that value that we calibrated by hand.
Great. I'm going to try and put this in the EQ because I think the ramp still doesn't work on that baby.
And there are other ways of doing followers. So this is just one implementation, which is a slow limiter. It may not be the best. We'll actually need to look into other options in the future, but it will be good enough for now. And then I think that we are in the middle of changing buffer something. What was this variable called before?
Pitch ratio smooth. It used to be called speed, no?
No, it used to be called buffer size. So I guess I am changing buffer size. That doesn't sound right.
But not max buffer size, right?
Yeah. Well, I do know that I want to get rid of the value that works well, and I did. So that's good. Let's return to the slider and we'll visit this section in a moment. So in the slider, we are computing this and we are computing smoothness, which we saw was actually crossfade. So I will just rename smoothness globally and I'll call it crossfade. And this is crossfading milliseconds coming from the slider. And I will converge from milliseconds to samples. And
cool.
That. Then we will need to find all the places where I had crossfade, because I forgot to say dot samples at the end. Yeah, I think I'm happy with this. I mean, look at the code that we have on the screen. It's looking great.
Yeah. So fast.
I wonder if there's something else that we would like to change.
I don't get line 21.
It is a way
We're
to
just saying
initialize...
one thing is equal to another thing.
So this is the initial value of the slider. We are in the init block. So the slider is going to start at 1.5. And this smooth version is going to be following the pitch ratio coming from the slider. So I do want it to start. It's going to be following that. And if I didn't say anything, if this line wasn't here, then pitch ratio smooth would be start at 0 and then find the pitch ratio of 1.5. So as you load the plugin, it would go like boop.
Oh, interesting, fun.
Right. Okay, so most of this I understand and like. Now let's see what we have in this big block of code. Well, we do know that there's this interpolation action that we want to implement in the circular buffer in the library. So let's take a detour and do that, because then it will allow us to come back here and simplify stuff. So in the circular buffer, there is this get function, right? So we will want to implement circular buffer get linear or interpolated linear, because we will do other kinds of interpolation in the future. So you take the circular buffer and you take the offset, which is now no longer required to be an integer like it used to. So now we want to get, for the linear interpolation, we want to get two samples. So first of all, let's check if the offset is fractional. Because if it isn't, then we could just call...
What is the offset in this case?
Oh, it's like you want sample... You know how in the RBJ cookbook they say like sample xn minus 1, which is one sample ago?
Ah, I see.
This minus
so
1
it's
is
like
your
if
offset.
you want two samples, offset is minus 1?
Yeah, so...
If you're interpolating two samples.
So you can think of this offset as this minus 1 situation here. So if you have your samples coming in, they will be like sample n minus 2, sample n minus 1, sample n... And if you had some sort of look ahead, you could even think about n plus 1, which we currently don't have a notion of look ahead in the circular buffer, but we could. And then the offset would be in relation to this look ahead.
Nice. That was so much typing before, so that's good.
So now we want to get... Well, let's just get a hold of the sample before and the sample after the offset. So let's say that the offset is like 0 minus... It always has to be negative, see? When I'm using the circular buffer, it always is like minus 1 or minus 2, because we are talking about n minus 1. So I always take the offset to be negative. So let's say that we are taking... we are interested in x of n minus 1.5. Well, that guy we know to be between x n minus 2 and x n minus 1, right? That's where it lives. So we are interested in, I guess, the floor and the ceiling, but I don't really know how JSFX is going to compute the floor and ceiling of negative numbers. Is it going to do the right thing? Let's check. I can come in here and say something like floor of minus 1.5, and I expect that to be minus 2. It is. And ceiling of 1.5, expect to be minus 1, and it is. So it does the right thing. Great. Now, all I have to do is to take the floor. So this guy is the floor. This guy is the ceiling, right? So I can just use this to get that. I guess I will call this maybe x n minus 2. I mean, or maybe let's consider samples minus 0.5. Or maybe even let's consider samples minus 75, because this is not right in the middle, which will make our tests a bit more interesting. So let's say that this is sample n, and this is n minus 1. So we can reason about things this way. How about that? Making sense so far?
Yeah.
And I will say
so
that
when
this
we
is
go
minus 0.
75, it's not like 4x oversampling. It's weighting one sample more than the other. Kind of deal,
Exactly,
right?
yeah, which boils down to 4 times oversampling, because we could request from this circular buffer all 4
like
of them.
0.5, then 2.5.
Or all 3 of them.
Yeah.
So I guess it's taking each sample and producing 4 samples, so it's 4 times oversampling. Right, so this is going to be xn, which is our ceiling. So I will take that with the ceiling of the offset. And our n minus 1 will be with the floor. Then we need to do these shenanigans to get the fractional part. So if it's 0.75, we want to get the 75. Of course, this is already a 0, so that's kind of boring. But suppose that our inputs were like our offset here was minus 3.75. So this would be minus 3. This would be minus 4. And we are interested in getting the 75. To do that, we take, I guess I'm going to call this the weight, or I'll call this the xn minus 1 weight, and that is offset minus the floor of the offset, or is it? How do I get the 75 out of this? I will take minus 3.75 and I will add 3 because that's equal to 0.75. So where do I get this plus 3 from? Well, I can say minus 3. Minus 3 is this guy. So if I now replace this with my variables, I want that. I guess I will reorder this to read like that. This is what you gave me, so that's the offset. And what is minus 3? That is my ceiling. So minus the ceiling of the offset. Yeah.
I thought your floor was minus 4. Oh, you do want the ceiling. You don't want the floor. Yeah. Sorry, I'm down.
So I guess this will be the correct formula. Because we are working with negative numbers, everything is reversed. And now we can note that we are computing the ceiling twice. This is just annotations, but we are computing the ceiling twice. So let's say offset ceiling. And then we don't really need, but just for symmetry, let's do that too. And then we have the weight, which seems to be right. All I have to do is just say ceiling. And then we can return using this formula over here, but with hopefully better names. So it is xn minus 1 times its weight plus xn minus, or not minus, just xn minus 0 times 1 minus the weight. Now, I think that this makes sense. Do you think it makes sense, Arya?
It does to me, yeah.
Okay, so let's try this. I will comment all of this out for a moment. Later, I will remove it. But to try this, I will need to say that all these variables are local. So let me go ahead and do that. And then let's write a test for this. So if I want to get a linear interpolation of, so I have this circular buffer where I have the values 1000 and 10, 20, and 30. So let's take minus 1.75.
Somebody in the chat, Roblox Gamer, says makes no sense to me, but I'm glad you're doing it. I must add, I'm not a programmer at all.
Okay.
That makes two of us, buddy. But yeah, like it's kind of actually like it. I wouldn't be able to write this, but it's pretty simple. Like you're just taking values that are samples, and you're drawing a line between them, and you're creating samples in the middle of these lines, which is like what oversampling does. It's kind of nice.
Yeah. And we are doing... so let's think about this for a moment. We have here in the circular buffer, we have samples. 1030 and 1020 in positions 0 and -1. So what is in sample -1 or minus half? What is in between?
125.
It is...
Or 1025.
1025. Right? So that makes sense. And by the way, thanks for being here, Bird Brains saying Roblox Gamer. It's great to have you here. I hope you enjoyed this. So that test makes sense. Let's write one more. Let's do 175. So we are almost at 2. We are 3/4 of the way between 1020 and 1010. So that is...
So 10, 17, 50.
No, I don't think so, because we are closer to -2, so it should be that, shouldn't it?
Oh, sorry. We're between -1 and -2, and we're close. Oh, yeah, I see. Yes, you're right.
Okay, so all of this checks out. These tests should pass, I guess. How about we load tests, and then we have a syntax error. Great. X of n is unhappy. Semicolon. Shout out to my fellow Arya. There you go. Circular buffer tests are failing. So now we have to dive into the library and find out why they're failing.
That test thing is very cool. I saw the stream where you did it, and I was like, I didn't fully get it, but I appreciated the point of them. Is it possible that we went too grainy with like 1250? It needed to be an integer?
I sure hope not. I sure hope that this works for any values that are fractional. In fact, rarely we'll have a sample that is 1000. Usually we have samples between -1 and 1.
You better hope not to have that yet. Let's see.
So I'm trying to get things from this circular buffer. So let's see if this circular buffer is a value that makes sense. It's not. So it seems like in the library, it's not able to get... Oh no, this actually is the address.
Because it's saying local circular buffer.
So I guess this was the first thing I allocated in my tests. No, it isn't. Or sorry, no, that's not a test. No, but no, it isn't. It shouldn't be. So what's up with that? Why do I have circular buffer here as a variable? That is not right. Let's see if there is something that stands out. How many references do I have to this variable? 2 references.
2. There's no like right click go to ref, I guess, in the IDE.
Yeah, no, there is nothing like that.
My God, why are people texting me? Guys?
That's odd. Let's revert our changes real quick. So what if I just comment out all the tests that have to do with the circular buffer? And I even comment out this whole implementation. Then when I reload this, the circular buffer variable is gone. Okay, so the issue is in here somewhere. Did I forget some variables in here? No, that's not the case. And then I do have a circular buffer local here. So that shouldn't be an issue, but still it seems to be. So these were the
When
tests I
it's
wrote
local,
before.
it still shows up in the IDDE, right? Like
It should
just
not.
shows as one. Oh.
Okay, so far so good. Then let's bring in this other test.
Easy, come on. What are you? Why?
Okay, so far so good. So what's up with that? And now it doesn't show up anymore.
Took care of itself.
It still doesn't work. It's still failing. And the variable is no longer there, so yikes.
Ah.
If I do a full compile reset.
Easy. What?
Oh, I guess it is because I computed something. Okay, so let's do this again. I will run this block of code. And now we do have a circular buffer, which is a weird value because I allocated that value. Right now, that's the address of the circular buffer. Then if we look into that position, it's 1030, like it should be. Now, if I look into this position, it is going to be 1010, like it should be. Okay, now we can look at what this is returning. What is this returning? Oh, it's returning 1035?
But it's between 1020 and 1030. So, what the hell? Wait, are the floor and ceiling need to be just flipped?
Seems to be. What happens if I reverse them here?
Put that thing down, flip it, and reverse it.
Well, then we also need to reverse it here on the weight, right? I don't know. I will just test, and then if it works, I will try to understand it.
Because you're doing offset minus offsets. Yeah, I guess let's do that.
Okay, that's 1015 now.
So that's wrong too. I think what it is offset minus offset ceiling. Oh, that was to give us the fraction.
Yeah,
is it giving us the fraction?
Let's really reason about this step by step to figure this one out. And that will be that, actually, because time is up. So let's really figure this one out. I will take out these comments because obviously that reasoning didn't lead us to the right place, right? So our offset of minus half at what is the ceiling? How can I do this? I guess I can do something like this. I can say offset equals minus half. And when I evaluate this, then the offset variable exists. Then I can look at the ceiling and the floor of offset, and then these variables exist, 0 and -1. So far, so good. I am interested in what is halfway between 0 and -1. Then what is xn? I expect xn to be 1030. And xn is 0. Oh.
But the circular buffer is now 0. So you got to do that scan thing that you do. Yeah, that thing.
Okay, second try. Xn is 1030. That's right. Then this I expect to be what? What do you expect this to be, Arya?
1020.
Yeah, I agree. 1020. Then what is the weight? It's supposed to be... Oh, the weight is negative, isn't it? Yeah, the weight is negative.
Because it's xn minus 1, which is a negative value. So we got to kind of, whatchamacallit, times it or this make the square root of that thing times 2. Is that how you get rid of a negative sign?
I could just take the absolute value of this, but I do want to rethink my logic before, because I had it in a comment and it doesn't seem to be right, but I was convinced before that it was right, so something is off. Let's think about this for a moment. What if the offset is not minus half, but minus 3.75? How do I get to the 0.75? That's what I want. I can, before I said I can add 3, but that leads me to minus 0.75. What if instead I had 4 minus that? Do I have a 4 anywhere? Well, I will take
you have the ceiling of the thing, no?
Actually, the floor. The floor is minus 4.
Yeah.
But I will have to take the absolute value of that. So I might as well just do the absolute value of the computation I already have on the screen, right? So I can take this value out. I can take the absolute value of this. And then I can do a full compile reset. And now the tests are passing. Great. So we did linear interpolation. And that means that we are able to now clean up a lot of what's going on here. A lot of what's going on here is us getting samples and computing the linear interpolation. This formula appears here and there.
Beautiful.
Yeah, okay. Tests are passing. Code looks good over here. I think there could be a way to make this faster. So I'm going to leave here a fix me. Don't call .get, but compute the samples here, because this .get situation does have to access memory and then do some computation, but then it's like throwing all of this information away only to get it again on the next call to .get. So if I inlined the body of the logic of the .get here, it would make things faster, but it's correct now. It's just slower than it can be. Can be faster. Okay, all of this looks good on this side. I will commit this. Then here on the pitch shifter, we need to reason about how we are using all of this. So we will also do the crossfade and everything. That can get a bit complicated. And we'll do the slicing, so, right? The grain, which is slicing the buffer. So it's not just the linear interpolation, it's also the slicing, and even the read head needs to advance based on the ratio. So I don't think we have time to continue doing this right now. So for next time, we are going to tackle this block of code, use what we just developed for the circular buffer, and maybe even on my other streams where I do the library stuff, I could just do what we need. We need to be able to slice a circular buffer. So I may get to that, and then we'll have the library function we need to simplify this even further.
Would it be possible if you have a function called like sampling, and as an argument it takes how many x over sampling it does? Would something like that be possible?
So something like this for 6 times oversampling?
Yeah.
Yeah, I think that maybe the way we could do this, something that we will need. Because what we are doing is not necessarily like 6 times oversampling. Right now, what we are doing is really just interpolation. We are just trying to find samples in the middle. We don't need to, for the entire circular buffer, we don't need to upsample it 4 times. We don't need anything like that. So this is a different task that you are talking about. And I guess we would need to have some sort of data structure, because for oversampling, you need not just a pair of samples. Like for linear interpolation, you can do it with a pair of samples, but usually you want more samples to do a better job in interpolation. So you would need to store some data. So you would need some sort of oversampler, and then I guess you would need to allocate some data structure for that. So I would go with something like oversampler new, and then maybe let's say that you are doing sinc interpolation, which is one of the best ways in terms of quality. It's also one of the slowest, but still. Then you could do something like 4 times interpolation using, I don't know, 128 samples. What does REAPER do? If I try to render a project, I
think you can choose a bunch. So 192.
Medium quality 64. So we could have like 64 here. So this is going to be...
So from the 64 samples, it kind of like gets the direction that the thing is going, so that the interpolation is not just like connecting 2 dots, but it's like more kind of following the flow of the signal.
So you want to know how sinc interpolation works? Is that the question?
I guess if you have time and if it's a short answer.
It is a relatively short answer. So let's look at a waveform somewhere. Okay, here I will add a track. I will add my own voice to the track.
Easy, you're driving me.
And then I'll start recording. And then we have a waveform to look at. Now, let's zoom all the way into somewhere where the waveform is interesting. And understand how sinc interpolation works. Okay, so how does sinc interpolation works? Actually, sinc interpolation is what's used over here to show this drawing, to show the little line between the dots, because the samples are the dots. And then sinc interpolation is what is used to compute the lines between the dots. And it's kind of hard to tell because these lines are so smooth anyway. But if I had anything like a click, we would be able to see that. But let's not. But how does sinc interpolation works? It works like this. Let's say that we have a sinc interpolation of 64 points. You're going to store 64 points worth of this. So you're going to slice it here and there with 64 points. And let's say that you are interested in this point right here where I put this marker.
Yeah.
Well, you will need to be somewhere right in between. So 32 samples to the left, 32 samples to the right, okay? So far, so good. Does this make sense?
Yeah.
And if you're interested in doing like 2 times oversampling, you are going to be right here in this marker. If you're interested in doing 4 times oversampling, you will have to have 1 marker over here, 1 over there, and then 1 over there. Right? 3 markers here in the middle. But you're interested in doing 2 times oversampling using sinc interpolation with 64 points. So you need this much of look ahead. That's why oversampling introduces latency. Well, most kinds. There are other kinds of oversampling, like for guitar pedals. If you want to emulate a guitar pedal, you want to do some other kind of oversampling that does not require look ahead because it does not introduce latency. But this is the most typical one. It will introduce some latency because it needs to look ahead. And then what it does is it takes this sample over here and computes the sinc function. The sinc function is just the sign of this value divided by how far away it is from my marker. So if it is close to my marker, this distance is small. So the weight of this sample, this dot, the weight is large. This sample is going to contribute a lot to the marker. And then it goes further and further. It computes the sinc function. So it computes the sine divided by x of all these samples. And the further they are from my marker, the less they contribute to this. In the end, you're going to sum everything up. So the less they contribute to this summation. So for samples that are further away, they still contribute to this because whatever happened in the past is still affecting, right? If you think of this as like the position of the speaker cone over time, which more or less this curve is, you can imagine that because the speaker had to go all the way up here in the past, inertia tells me that this point is still affecting the movement over here. Like the speaker had to go over there and it's bouncing back, and some inertia is still in effect. Now, it will be very small amount of energy, but it's still affecting this sample over here. So, and by how much? Well, the Shannon theorem, the theorem that tells you that band-limited signals can be represented with particular sample rate and blah, 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 tells you that the effect that this has is based on the sinc function. So you just take the sinc function, which is like the sine of this guy divided by the distance between the guy and the point we are interested in. In a nutshell, that's sinc interpolation. That's what REAPER does, which you can imagine. To have good results, you want a bigger window because you want to see more in the past and future. And the more you do that, the more signs you're computing, and you have to divide by x. So division is expensive, like we said before. So it becomes very slow. It's also very good in terms of quality, but it is very slow. And
this, for some reason, reminded me of like astrology and the way that it's debunked, because like the effect of gravity on two objects is like mass the first one, mass the second one, divided by distance squared. So like if people believe that the position of Mercury at your birth has an effect on your personality, well, if there's like a nurse next to you, okay, the mass of this nurse is a lot smaller than Jupiter, but also the distance is a lot crazier. And since distance is squared, the mass is closer to you always wins. For some reason, this reminded me of that.
Yeah. Yeah, so in a nutshell,
is this distance only, like the distance matters like on two axes, right? Like, so if the point is higher and further back, you make a line, or I guess sine determines that.
Yeah, no, it's only the distance on the x-axis, only how long ago or how far in the future that sample is. It does not matter if there is like a click. So one sample is very different from the next because one is like at 0 and the next is at 1. Then it doesn't matter. I mean, in fact, okay, I will bite the bullet. Let me create an item, find my... Probably there is a smarter way of doing this, but that's how I am doing it now. So now we have a train of impulse. So it's just one sample that's 1, followed by a bunch of samples and preceded by a bunch of samples that are 0, right? The dots are 0, 0, 0, 0, 1, 0, 0, 0, 0. This is an impulse.
Yeah.
And you can see the shape of the sinc interpolation. It doesn't look like a sinc. Now it does, because I was zoomed into the waveform, so it was clipping at the top. But this is what the sinc function looks like. If you plot the sinc function, it looks like this. So you can think of sinc interpolation as just taking this shape. So this is the sinc shape. And you can see that it dies off on the screen after like 4 samples to the left. But if you zoom all the way in, you can see that it's the 5th sample now creeps in. And if you zoomed more, which I am not able to do in REAPER, but if you zoomed more, you would see that more and more samples contribute to this. And the contribution is less and less and less, but they still contribute. And this contribution adds up because you are adding up all these small contributions from the other samples. So you can think of reconstructing the sound as taking one of these impulses, which forms this shape, then overlapping it with another one of these guys, and then overlapping it with another one of these guys, and then overlapping, and then overlapping, and overlapping, and then overlapping, to make up any shape you want, like this.
Cool. Nice. So when Justin was also saying that he's trying to make like the peaks calculation faster, that would be like using a different type of sinc interpolation, or possibly like a fine or less fine grain of a, like using fewer points.
I will think about that in a moment, but I do want to actually show the concept. So on a folder, oh, that's just ridiculous. On a folder, Reaper is going to show me the addition of all the waveforms, or is it going to just show them, all of them superimposed?
It just superimposes them, yeah.
But I think that will do. So hang in there. All I need to do is glue this and then copy and then shift it around a bit, but make sure that it's on the folder. Yeah, all right. This figure is nice. Yeah. So let's have another copy. And let's have just a bunch more. Great. And then we can shift this around. Isn't this the concept of a fun afternoon for you all? So you take all these sinc functions and they form all these shapes, and you superimpose them and you add them up. That is how you can reconstruct the signal. So when we say that a signal can be sampled and then reconstructed perfectly as long as it's band limited, and as long as the size of the band is less than half of the sampling rate, that's the Shannon theorem, the Nyquist frequency and everything. So as long as all of this is respected, you are able to reconstruct the original analog waveform perfectly, losslessly. How does that work? Well, it works like this. You just take all these impulses, you overlap them like this, and you add them up. How do you add them up? Well, you right-click, you render to a mono stem track, and this is the waveform you get. Of course, it's clipping because it was too loud, but you get it. It was just overlapping all those shapes. So that's how you can reconstruct the analog signal using Shannon's theorem. And that's how you can do oversampling too. It's the most proper, I guess the most correct way, even though it's kind of slow, but it will be like for showing the points here. That's not too many points. Like, what is my screen size? It's a 4K monitor, so it's 3000 points. You can compute 3000 sine functions real quick, so you can display this form perfectly. So this is the analog perfection. And of course, to make it really, really perfect, you would need to consider all the infinitely many points in the past and in the future. But Reaper seems to think that as long as you have 768 points, you're probably good enough, and then you can truncate after that.
Right.
Okay. Does that answer the question about interpolation?
Yeah.
I hope that was entertaining.
Yeah.
Right, and you were talking about something else. Justin talking about the computation of these peaks, right? So I think we haven't really talked about this with Justin, but I think that the way the peaks are computed is they have like different flavors. There is this flavor that is zoomed out, and this is like just taking the maximum and the minimum of the waveform over some period. This is what I have been doing on the stream like last week. So people who are interested can go watch my streams from last week. And then as you zoom in, there will be like finer grained versions.
Yeah.
And then
you even see sometimes the change. Like when you get to dots, you will see that.
Yeah, right here I can see a
happen.
change too. So this looks like a thick line. So it's probably the maximum and the minimum in the range. But as I zoom in, it becomes a single line. So I guess now it's just taking one sample. And then when I zoom in more, you see the dots now. So I think that he's like, the way that the peaks construction works is probably it's looking at the waveform, taking the maximum and the minimum over a window, and then it's not bothering computing these dots, right? Because the dots you might as well just get from the file underneath in real time, because it boils down to the same. If you wanted to compute, if you wanted to store all the dots, you would be storing the wave file. But what Justin was talking about is that, at least to my understanding, is that Reaper, when it sees like 10 files, it goes over the first one, then the second, then the third. And what Justin was doing or is doing is take CPU core number 1, you analyze this file. CPU core number 2, you analyze this one. Parallelize the job of going over the waveform or going over the wave file and computing the maximum and the minimum to do the drawing. So it is just taking advantage of your CPU cores to parallelize the task and make it faster. And if you're using spectral peaks, there is even more work to do, because you do have to compute the FFT of the thing, try to find the peak, or maybe that's just one way of doing it. You could do it in the time domain as well, I guess. But you do need to do some extra work to compute the peaks. And you can parallelize that using the CPU cores. And then if you load a whole session, like Justin had a recording of his band, 10 files, 16 files, you throw them into Reaper, and Reaper is going to take advantage of all your cores to speed the process up. Or maybe even, since this is such a parallelizable task, each file is independent, but also each chunk of the file is independent. Even if you had a single file that you dropped into Reaper, then you could say CPU 1, take care of this chunk, CPU 2, take care, CPU core 2, take care of this chunk, CPU core 3, you do this one. And
you see that when you have like a 1 hour long file, you actually do see it going through it in increments. And loading them up.
Now, this could be just, I also know this, but yeah, it could be just a presentation thing. It could refresh the screen every so often or in particular way, but it seems like that's what's happening underneath as well. And another thing is, it could, as Justin was saying, there are different CPUs with different processing powers. So you could say like CPU core, which is for efficiency, take this chunk. CPU core number 2, that is for efficiency, take this chunk. Now, CPU core that is for saving energy, you take this chunk because you're slower. So you take a smaller chunk.
Right.
So maybe that's what he's into. I don't know. But it could be that.
Also, here's a new thing that nobody knows except if you're one of the 5 watching this video. How does next Monday sound to you for chatting with Schwa?
Yeah, sure. Let's do it.
All right. So you heard it here. Tell everybody you know. We got Schwa in the house.
Yes. Okay. So I'll just double check now. But yeah, next Monday should be good.
Cool. Well, lots of fun. I know we went way over time. I got to go too. So, pow. Thank you as always, Leandro.
Yeah, thank you for joining me here. Now you were the guest, I guess. So, tomorrow I'll be back. I will be working on the library, and I may be doing this slicing thing that we need on the circular buffer. And we'll be back on Friday for some conversation about audio production. I'm not even sure what we are going to talk about, but it will be fun, and we'll be together on Aria's channel on Friday, right?
Yeah.
Right.
Cool.
Thank you, everyone, for watching. Thank you for subscribing to the channel and doing all that good stuff. You know what to do. And I see you tomorrow. Bye.